This is semester 2 exam review. So let's start from number 1. The first, second, and third terms of a geometric progression are 2p plus 6, 5p, and 8p plus 2, respectively. Find the possible values of the constant p. So since this is a geometric progression, so the ratio between the terms are equal. So 2p plus 6, 5p, and 8p plus 2. They will have the same ratio. So I can make an equation of ratio equals to the second term divided by the first term, as well as the third term divided by the second term. So I can cross multiply. So it's 25p squared equals to 2p plus 6, 8p plus 2. 25p squared equals to 16p squared plus 4p plus 48p plus 12. So 25p squared equals to 16p squared plus 52p plus 12. And we simplify 25 minus 16, 9p squared minus 52p minus 12 equals to 0. Now we try to factorize. Can we factorize this? 12 to become 52. 12 is 6 times 2 or 9 times, okay, 6 times 2. Okay, I got it. So this is 9p, p. So this is 6, and this is 2. So 9 times 6 is 54. So minus 54 plus 2 to become negative 52. So p is equals to negative 2 over 9, and in here p equals to 6. One of the values of p found in A is a negative fraction. So we take this, use this value of p to find the sum to infinity. So p is negative 2 over 9. Find the sum to infinity. So the sum to infinity is equals to a over 1 minus r. So what is a and what is r? A is 2p plus 6. So we can put 2p plus 6 over 1 minus r. What is the r? R is 5p over 2p plus 6. So find r, 5p over 2p plus 6. So we replace the value of p, negative 10 over 9, divide by negative 4 over 9 plus 6. So what is this? We can use calculator. Negative 10 over 9 divided by negative 4 over 9 plus 6. Equals to negative 1 over 5. So this is negative 1 over 5. So the first term is equals to, what is 2p plus 6, yeah? Negative 4 over 9 plus 6. 50 over 9. So 50 over 9 over 1 minus 1 over 5. It is 6 over 5. So 50 over 9 divided by 6/5 equals to 125/27. Yeah, that's number 1. Move on to number 2. The sum of the first two terms of a geometric progression is 15, and the sum to infinity is 125/7. The common ratio of the progression is negative. Find the third term of this progression. Okay, the sum of the first two terms is A plus AR. Yeah, the first term is A, the second term is AR, equals to 15. Okay, we have one equation. Another equation is the sum to infinity. So the sum to infinity is equals to 125/7. What is sum to the infinity? It's A over 1 minus R equals to 125/7. So we have two equations. Now we can do simultaneous equation. I can do from equation number 1, I can factorize A, 1 plus R equals to 15. So A equals to 15 over 1 plus R. And I put it in the second equation. So A is 15 over 1 plus R divided by 1 minus R equals to 125/7. So I can combine this 15 over 1 plus R, 1 minus R equals to 125/7. This 15, 1 minus R squared, yeah, equals to, yeah, 1 plus R, 1 minus R is equals 1 minus R squared, yeah, special factorization, 125/7. So can we simplify? Okay, so 1 minus R squared times 125 equals to 15 times 7, 105. So 1 minus R squared equals to 105 divided by 125. So 1 minus R squared equals to, divided by 125, it's 21/25. So R squared equals to, so 1 minus that is 4/25. So R can be plus minus 2/5. But in here, the ratio is negative. So we take R equals to negative 2/5. So from here, we can say the R is negative, and we can find the third term. So the third term is A R to the power of n minus 1. A R to the power of 2. Yeah, n is 3. Yeah, 3 minus 1. So A R squared. So we put A. What is A? No, A we found from here. 15 over 1 plus R is negative 2/5. And this equals to 15 divided by 1 minus 2/5, 25. So this is 25 times R is negative 2/5 squared. So 25 times negative 2/5 squared. It's 1. So this is the answer for number 2. Move on to number 3. Number 3 is Function f is defined by f. Express fx in the form of completed square, where a and b are integers. So we can rewrite negative 2x squared minus 8x minus 13. So we can factorize the negative 2, become x squared plus 4x minus 13. I factorize the first two terms. And then I can do the completing the square for this part. And I copy the others. They the same. So to complete it, the square form is x squared is x plus 4 become plus 2 and then minus 2 squared. So it's negative 2 x plus 2 squared minus 4. Yeah, don't forget the bracket. And then now we open the bracket. It is x plus 2 squared plus 8 minus 13. So negative 2 x plus 2 squared minus 5. Find the range of f. As we know, this has vertex negative 2, negative 5. And since the coefficient of x squared is negative, so it will be a maximum point, maximum vertex. So the range will be for x smaller than negative 3. So the vertex will be negative 2, negative 5. So x is smaller than negative 3. So the domain doesn't start at the vertex. It starts at here. X equals to negative 3. So we cannot take this vertex as the range. So we have to find first the f negative 3. So I can just put it negative 2, negative 3 plus 2 square minus 5 equals to negative 2 times negative 1 square minus 5. So this will be negative 2 or will be negative 7. So the range will be y is smaller than negative 7. So don't use the vertex since the domain doesn't start from the vertex. It started from the other point. Find the expression of f inverse. So we use the completed square form y equals to negative 2 x plus 2 squared minus 5. And then we switch x and y. X equals to negative 2 y plus 2 squared minus 5. So we move the negative 5, x plus 5 equals to negative 2 y plus 2 squared. So I divide by negative 2, x plus 5 over negative 2 equals to y plus 2 squared. So y plus 2 equals to square root of x plus 5 over negative 2. This is plus minus. Since the domain is smaller than, so we take the negative. So y is negative 2 minus root of x plus 5 over negative 2. I want to remove the negative sign inside, so it is negative x plus 5 over 2. Okay, so this is the f inverse. Number 4. Function f and g are both defined for x element real number fx and gx. Express fx in the form of completed square. So x squared minus 4x plus 9 can be expressed as, we copy this, plus 9 this first second term become x minus 2. Don't forget minus 2 squared. So x minus 2 squared minus 4 plus 9 equals to x minus 2 squared plus 5. Express gx in the form of, okay, completed the square again, 2x squared plus 4x plus 12. So I can rewrite as, I can factorize all by 2. So x squared plus 2x plus 6. Now I completing the square for this. Squared minus n plus 6, don't forget, yeah. So x squared become x plus 2x become 1 minus 1 squared. So it's 2 x plus 1 squared minus 1 plus 5 plus 6 equals to 5. Okay, so yeah, we have the same. Yeah, the same form, yeah. See, express gx in the form of kfx plus h, where k and h are integer. Okay, what is gx? Gx is 2x plus 1 squared plus 5. Gx 2x plus, what is it? 1 squared plus 5. 1 squared plus 5. While fx is equals to x, what is fx? Minus 2 squared plus 5. Minus 2 squared plus 5. So how do we change gx in terms of fx? So we can see in here the gx is 2 of, we have negative plus 5 here. So I can change to make it the same, x plus 1. I can make it into x minus 2 plus 3. So I change the x plus 1 here into this by separated 1 as negative 2 plus 3. Yeah, this is still equals to 1. But I made this because I need the form of x minus 2. So I need to show the x minus 2 here. So I can rewrite this as 2 of x minus 2 plus 5. This is the same as f x plus 3. Yeah, 2 times fx plus 3. Yeah, because if I put fx plus 3 here, I will have x plus 3 minus 2 plus 5. So this is equals to x plus 1. So exactly the same. So this is the expression. Describe fully the two transformations that have been combined to transform the graph of yfx to the graph gx. So we can see that gx is 2fx plus 3. Gx equals to 2fx plus 3. So there are two transformations here. The first one is here, horizontal translation. So this is plus, that means it's going to the left, negative 3, 0. And the second one is a vertical stretch. By the scale factor of 2. Yeah, order doesn't matter. Number 5. A tool of putting funds into the ground is called a post rammer. The distance in millimeters and the post sinks into the ground on its impact of the post rammer follows a geometric progression. The first three terms impacts cause the post to sink into the ground by 50, 40, and 32 millimeters respectively. Verify that the ninth impact in the first in which the post sink less than 10 millimeters into the ground. So from here, this is a geometric, yeah? Geometric. So we can find the R. R is 40, the second term, divided by 50, equals to 4 over 5. And the first term is 50, so we can find the U9 is A R 9 minus 1 is 50 times 4 over 5 to the power of 8. So 50 times 4 over 5 to the power of 8. It is 8.39 millimeters. So this is less than 10. Yeah. But we need to check that the ninth impact will be the only one or the first one that sink less than 10 millimeters. So we check for U8, 50, 4 over 5 to the power of 8 minus 1 is 7 equals to 50 times 4 over 5 to the power of 7. So this is 10.49. So this is greater than 10 millimeters. So verified that the ninth impact is the first that less than 10 millimeters. That's for number 8. B. Find to the nearest millimeter the total depth of the post in the ground after 20 impacts. So we find the total is the sum of the 20. So A, 1 minus R to the power of n, 1 minus R. So A is 50, 1 minus the R is 4 over 5 to the power of 20, 1 minus 4 over 5. So this is 1 minus 4 over 5 to the power of 20 times 50 divided by 1 over 5. So this is 247.1 millimeters. So to the nearest millimeter, so for 247 millimeters. Find the greatest total depth in the ground which could theoretically be achieved. So that means we find the sum to infinite. It's A over 1 minus R. So, theoretically it will be 250 millimeters. 6. The sum of the first 20 terms of an arithmetic progression is 405, and the sum of the first 40 terms is, find the 60 term of the progression. Okay, this is now arithmetic, yeah. The sum of the first 20 terms, so this is S20, equals to 405. So we have 20 over 2, 2a plus n minus 1, 20 minus 1 times d, equals to 405. So 10 times 2a plus 19d equals to 405. That's the first equation. And the second equation, I can write the sum of the first 40 terms. So S20 of 40 equals to 1 4 1 10 1 0. So it's 40 over 2 to a plus, so 40 minus 1 times d equals to 1 4 1 0. So it's 20 to a plus 39 d equals to 1 4 1 10. Okay, so I divide by 10, yeah. So 2 to a plus 39d equals to 141. Okay, now we have to do simultaneous equation. How do we do this? I can, okay, just divide, yeah. So divide by 10, it's 2a plus 19d equals to 40.5. This one divided by 2, 141 divided by 2, it's 2a plus 39d equals to 70.5. So we minus, cancel this. So I minus, it is 39 minus 19, 20, d equals to 70.5 minus 40.5 is 30. So d is 3 over 2. A is, so we just put it to the first term, first formula, 19 times 3 over 2. Okay, 40.5 minus answer, divide by 2. So A is 6. So find the 60 term. The 60 is A, R, A plus 2 n minus 1d. So 60 minus 1 times 3 over 2. 6 plus 59 times 3 over 2. 94.5. Yeah, this is number 6.